All right. Thank you, Jessica and Dusty, for kicking us off. As Dusty said, I'm Michael Leners. I've been a developer for just over 2 years now. As I said earlier, I'm originally from Washington State, but I've lived in Iowa for just over 6 years now. So last summer, I got the Iowa transplant sticker because I feel like the Iowa captive sticker is a little bit too negative connotation. So I had a previous life as a chemical engineering graduate student and undergrad studied bioengineering. And then I moved away from the engineering discipline after getting my master's degree and taught physics and physical science for a couple years at Grandview University. That was kind of the opportunity that was afforded to me. They ended up rehiring for that position, hired somebody with a PhD in physics, and I needed a career. And I was looking into development programming for data science, actually, because I really loved the research side of what I was doing as a graduate student and taking data and presenting it. I realized, though, that a lot of the data analyst positions required a lot of experience or degrees, but what didn't was web development. I went for some internships and ended up landing a position where at IMT Insurance, where I was able to work on web applications with Ember.js and Django. And I've really found that my interests gravitate towards user experience, both on the user side, like who we are developing applications for, but also on the developer side, what is it like to use a tool or a code base? And I'm really interested in QA as well, because I feel like the quality of your application goes hand in hand with whether or not it does what the users want it to do and whether it does what the business wants it to do. So that's kind of how I found myself to this venue, talking about testing. I now currently work at Cardinal Health, working on React front end and Flask back end. We process a lot of medical and pharmacy data to try and identify patients that might need to be consulted by pharmacists who are at patients who are at risk. So that's about me. I love learning new things and sharing. That's also why I'm here. But you probably want to know more about what the topic is. So let's get going. I'm going to share my screen here so we can start the presentation. And I'm going to see if I can have you guys test out the technology real quick. So there's a few things. The chat area, I'm going to go ahead and put in, oh, I'm not sharing yet, am I? Okay. Can you all see the screen? All right, I see a thumbs up. Oh, and David got that in the chat. So that is a place where if you have a question or a comment, if you want to say something and you don't want to interrupt, feel free to shout it out in the chat. And I'm also going to throw out there a link to this presentation. You can also raise a hand. That's an option, and it'll show up by your photo, but I might not see it. I'll be watching the chat though, and I will ask some questions throughout because I've had my set of experiences and have my set of opinions. I try and present options in a way of like, this is what I've seen and things that work. But I'm always open to different ideas and want to hear what people have experienced out there. So occasionally I might ask for audience participation. If you don't want to yell it out, unmute yourself and yell it out, you can feel free and put it in the chat. All right, so cybernetic entomology. There's always one more bug. I enjoy trying to find interesting titles, and I came across this term, cybernetic entomology, and thought it was pretty great. And it's true. You know, given enough time and enough user base, there's always going to be something found in your application. So we're going to be talking about different layers of testing that can minimize that. I heard you shared the link here, so you don't need to scan the QR code to get it. Already talked a little bit about me. I do love coding, games, and crafts, and I actually have here my current crochet project. I'm building a one-up mushroom in the end. That's my meeting time. If we have a meeting that I don't have to actively be doing something, just listen. That helps me keep my hands occupied so I don't browse Amazon or Facebook. So why are tests important? This is, you know, why do we do them? Any ideas out there? I like this example. So a lot of times we do things on a system locally and everything works fine. And then we put it out there and it brings it out into the wider system and it doesn't quite work. So we had some responses also providing clean code. Everything always works the first time. Yep, it certainly always does. So some of the things I said, you know, if you don't test your app, your users will. It acts as living documentation, and that goes with the providing cleaner code. And it also serves as a regression test suite. So, you know, computers are much better at doing repeated automated tasks than human. So instead of having somebody going and manually running all these tests every time, it's much better to have your test suite do it and to have your bases covered. So this talk is going to be centered around these areas. First, I'm going to talk about a test plan and coordination on a team around that test plan. And then I'm going to talk about different types of automated tests and give some code examples. And then I'm also going to talk about user testing and non-functional requirements. So I want everybody to test out the hand feature real quick. Let's see if you can find the raise your hand. Give that a test and then lower your hand. I want to get a sense of, okay, I see some clapping out there. That will work. Let's see. So what I want to know is who is actually like a QA person, like a QA engineer. Is there any QA people who write test cases and they're automation engineers, QA specific? Any of those roles out there?
Yeah, I'm a QA, but I'm mostly work on manual testing, not on the automation side yet.
So you're currently manual and going to be moving to automation eventually.
Yeah.
And then we have Sarah, who's also QA, and Marth. All right. And then how about on the developer side? I'm guessing a good majority of the others. Cool. So hopefully this will be a good, you know, that's quite a breadth, and it's kind of what I was guessing. So hopefully the code examples will be beneficial for those that aren't used to unit level tests, and hopefully the higher level stuff will be good for people who aren't in the day-to-day QA mindset. But like I said, we might give shout outs, opportunities, and I am open to ideas and feedback throughout this talk. So this is what can often happen when we let a bug go. You see the finish line, You see that bug coming up, you say you're going to deal with it later, and eventually it multiplies and keeps you from reaching the end. So it's important for us to take care of testing. So how do teams decide what tests are most important to maximize that bug extermination? Sometimes it gets dictated from the top down. This has happened to me before on teams where the QA leadership above us are like, here's a template and you get to fill out the template, but it's actually like a 15-page document that you get to modify. So we're basically saying, do these things, but also do your own thing. In that realm, it was a little bit difficult for us to find our own space. Also had teams where there's no real consensus on what testing is involved, and people just test what they feel like testing, and occasionally conversations happen, but it's not really in the foresight. And I think it's important for teams to come together, have a serious discussion on testing, have a common consensus, and assess their blind spots often. So some considerations are, what level of automation are you going to be doing? And what will your purpose for manual testing be? Are you going to be doing full regression suites, or are you just going to be poking around manually testing because you have regression suites automated? Also, when are you going to be testing inside of a sprint and outside of a sprint? A lot of times that big manual regression test comes before pushing to prod. You want to make sure everything's working. But then there's also unit and integration and end-to-end tests that you can write in sprint. Do those tests have to be finished before the story's done, or can they get written after the story? These are things that need to get decided. Also, data management. There's a lot of ways to generate mock data and provide mock data for your tests, and where those get stored in your repositories, who manages them, whether that data is representative. You know, a lot of times data changes, and from year to year even, data might get out of date or models change. So if you have a ton of data and you need to change one field on each of them, it can get cumbersome. So having a plan around that's important. You also might need a lot of data and a lot of different data, but a lot of representative data for load testing. So having a plan behind that helps a team move forward with their testing plan. Also, how are you going to organize your test cases? What information are you going to put in there? And how is whoever's writing the test cases, if you write test cases, how are those test cases going to convey the appropriate information to the developer and business so that they know what the test case is about? You also should consider your test around what your clients need. What do the applications need? So the way we tested an Angular C#.NET Core application is a lot different than the way that we're testing React and Python Flask application. What are the compliance needs? Is there certain needs around PCI or HIPAA, you know, certain compliance or compliance within the company? And what's the developer and QA preference and experience? Some people just really like writing Cucumber. I like the Gherkin and the way that you can integrate that with different systems. And you know, there was a big question between Cypress and Selenium on our team. And we were, as developers, writing the test and thought that Cypress was a lot easier to learn, whereas we had colleagues on other teams that knew Selenium really well. And so, you know, if you know that tool really well and it works for you, then you might want to go with what the developer and QA preference is. But again, it's important to have that conversation and to document what's important to test and to revise and revisit the plan often. It's one thing to write something out and then just set it aside and never look at it again, but this should be a living document that you revisit and revise often. we track down that bug and find out the real problem. Started back on sprint 1. And this goes towards Mike's statement on providing clean code. I've had an experience or two where I've been able to write fast and loose without testing just because of the team standards of not testing very much. And we couldn't even run our test suite because of unfortunate architecture planning situations. And the code you write is a lot different without testing. So to keep these big honkers from happening, it's pretty good to test often. So not all tests are created equal. So here's something I'm going to suggest for designating test cases, some information you can put in them. So what I'm talking about here is like in Azure DevOps, for example, we had test suites and our QA person could go in and say, this feature, we test it by doing these steps and this is the outcome. And she'd do that with pretty much the acceptance criteria you could take and make into test cases, translate pretty well. And so sometimes certain features are more important than others, right? And when you have bugs come up, they're more severe than others. So this is a ranking system that you can use to label test cases, stories, or even bugs as they come up. We labeled them with 1 being the most severe. A 1 means if this feature breaks or this bug is causing the application to be inoperable. It's a widespread issue and merits immediate attention. And then you scale it back down to a 4 to like, yeah, this is a low impact to business and may never get fixed. And you can see in between there, some of the areas around it is that just partially impacting business function and also whether or not a workaround exists. Like, not being able to submit a form is different than having to open a dropdown twice and then click the submit button to get it to work. If there's a workaround, at least it's like, not stopping mission critical. It's not really the best to have that bug out there that you have to do this weird confluence of things to get the submit button to work. But as long as there's a workaround, it at least isn't stopping business impact. How about that age-old question between scope and time? We've been facing some of this on my team recently where it's like, yeah, we want, like, scope is more important, but we got to hit that deadline. It's like, okay, sometimes you can't have both. So agreeing what's in scope and what's out of scope is important to get it done, right? So pertaining to tests, decide what's in scope and what's out of scope. So a lot of times code that we write is in scope, modules, components, services, etc. The data management layer. Out of scope could be, we know our users are going to be using a computer. This isn't mobile or tablet tested. We're not going to test any third-party APIs, maybe some integration tests around them, but we're not going to test their functionality. And we're only going to test for Chrome and not Internet Explorer. These were some examples of what's in and out of scope. We'll talk more about levels of testing between end-to-end and unit, and I'll share what our team chose to do for each of those areas so that we had, this is out of scope, we're not going to test this. This is in scope, and it's what's important to test. I'm going to go ahead and pause. I meant to pause earlier too. If there's any questions or comments on that or the testing plan conversation. Okay. So how do you communicate on a team around testing? There's lots of variables, right? Is QA embedded on the team or separate to the team? I've seen it in both ways where teams don't have a QA person, team has a QA embedded on the team, or QA is a separate department, like UX is a separate department, and they're separate from the developers, and there's the QA send stuff over to developers and vice versa. And who writes the test cases? You know, sometimes the product person writes test cases. The product manager writes the test cases. Sometimes the developers write the test cases. And sometimes QA automation engineers write the tests, and sometimes developers do. You know, it just depends on what the team is and what the skill set is. But having clear expectations up front is important, because if there's gray areas, a lot of times we find that if you think we're doing it or we think you're doing it, then nobody does it. A lot of some of the best practices we've had is for when we start a story to have a developer and a business person and a QA, especially the developer and QA, come together and whiteboard what the story is. This is what we're expecting, and then here's what we're going to test. And then the developer writes an end-to-end test to start with, and then give that to the business person and say, hey, is this what this feature is? Does this end-to-end test satisfy it? And then you can go and do your TDD cycle and make that end-to-end test pass, refactor your TDD tests, and then move on and reconcile with your QA and say, hey, this is our end-to-end test. How does it match up with your test case and the manual test that you're going to do? What our QA person would do when we did it in that cycle was they would run a manual test once when they wrote the test case and check it off, verify that our Cypress code or our SpecFlow code did what we said it would do, that did what the test case manual test was. And as long as it checked off, then they wouldn't have to come back and redo that test as part of a regression test, because they knew that there was a Cypress or SpecFlow test there for it. So what tests can you automate? So go ahead and throw it out in the chat or say it out loud. What kind of tests do you automate on your teams? Somewhat of a loaded question, because there's, I feel like the more I talk about tests and the more we look at them, the harder it is to find lines between them. All right, so repeatable test, basic functions, permission-based access, regression and functionality, unit integration API, security performance, smoke integration. So yeah, it's that line between regression, functionality, unit integration, and API, and end-to-end I'll also throw out there. Yep, anything that's repeatable. We said that was repetitive tasks are good to automate rather than having a human do them. So let's go through some of these. So this is the diagram that I was talking about. This looks at a simple architecture. A UI connected via an API to a backend. And this is kind of geared towards what we were doing at the time with Angular and our C#, where we had particular components on the front end and back end to break things up. So starting with end-to-end for a full stack like this, UI connected to the back end, we would, this little clicky is where our test entry is, and then this mask is either cross over it is not mocked, or if it's open, then that means it is mocked. So our home is our end-to-end tests, all the way from the user interface, all the way down to the bottom of the database. That is a full end-to-end test. it even gets fuzzy there. Our QA management said that they don't define that as just that as an end-to-end test. They think an end-to-end test is a user end-to-end flow. First, I do this, then I upload this file, then I edit this thing, and then I submit this report, and then I am done with my work. That is the end-to-end task flow tested, whereas we just thought as long as it went from the UI all the way down to the database, that's what end-to-end meant. So even there, your definitions get fuzzy. So let's take it down to unit tests. So these little bricks are the units. You can have on the UI, for example, service level logic, which for us was hitting APIs or doing some complex logic. Controller level logic could be unit tested, which takes your data from the service, your API calls, and gives it to your templates in your view. Your view was your HTML, CSS, and sorry, not JavaScript. So each of those could be distinctly unit tests. You can test your controller and say, when this component is initialized, it calls this service. You mock the service and assert that something was given in return. You could also activate a service and mock the API call. So for each of these levels, you can choose where you mock. And if you decide, you know what, I want to, in the browser or in the DOM, ingest or something, click around, and I want to assert that API calls were made, then you're going to be doing, it could be considered integrating your units. But then also one thing that's not included on here is another version of integration tests is making sure that this UI to backend interface, that this connection works, is your integration test. And there's certain tests that you can do around that, like packed testing, or I learned about Mountbank today, actually from a colleague, which is where you make API calls and Mountbank records your returned data. And then you can use that recorded session for your UI to hit so that you don't have to hit your API every time when you run your front end test. So that's your form of mocking the front end. Your API call from the front end using those recorded session calls. And then anytime you change your backend, you have to re-record the calls. But that way, you don't have to hit the backend every time and always do an end-to-end test. The same thing happens on the backend. Our controllers were our endpoints, our gets, posts, deletes, and all that. We tried to keep those really dumb. Our service layer was where we had all of our business logic, and our repository was our database access layer. We also tried to keep that pretty dumb too. And again, you can choose to mock or not mock any of these, and you can integrate it together. And so we chose to call our API tests or integration tests on the backend API tests. I'll go ahead and show you what we ended up testing for those. We'll work our way back up. We use SpecFlow to hit our API endpoints. We said, given this data is in the database, when I hit this API endpoint, I expect this to be the return data from the API call. Completely black box, totally ignoring the functionality, just say this data is in the database, I make this call and this happens. We did not unit test our database layer because our integration tests were connected to it, and it was because it was pretty low business logic, but we did unit test our controller and service layers. Working our way up, we did full end-to-end regression tests. Also, we had Cypress gives you the capability to mock API calls pretty easily. So we did our front end tests mocking API calls in Cypress. But again, you gotta watch out for that, because if we ever changed our API then we needed to go back and change our return data from those mocks. Going down into lower level, at first we unit tested in Angular, but using Angular's test bed proved really difficult. So we ended up nixing that level of testing and strictly unit tested our controller. So I call this service, and this data gets munged around and presented to the template in this way. Now, a lot of you are probably like, you didn't test your service layer, your layer where you're making API calls. Like that's kind of important that you take what you get from an API response and put it into the objects that you want it. What's really cool about using .NET Core and Angular is using OpenAPI CodeGen. It took our controllers on the back end, which had strongly typed models and post gets and all that stuff, and it automatically generated our services for us. So we did not write any of our services or any of those services that did HTTP calls. And because we knew they worked, because they were automatically generated, we didn't have to test them. So that's our testing strategy on that project. My current project, we're working on panning out our testing strategy. So what distinguishes a unit test from an integration test? And what is a unit test? You know, for a while, this displays it pretty well, right? Here, each unit is the lock and the sliding mechanism. And the integration is that the lock prevents or enables the door to slide. So you can make sure your lock works individually. You can make sure your door slides individually, but whether they work together or not is really important. And so, you know, you could consider your unit one function and your other unit is a different function, and do those two functions integrate together? Or you can say my front end is a unit and my back end's a unit, and do they integrate together? Or my API calls this auth service or this configuration service, and each of those is a unit, and do they integrate together? And we had a long conversation recently because we had end-to-end tests on the back end where the API was hit down to the database layer. That was end-to-end from the perspective of the back end, but it's not the end-to-end perspective from the consumer, which starts from the user interface all the way down to the database. So understanding what you consider unit and integration is important. But to even give you a little bit of an example here, this is a unit test example. Pretty simple. We have a square class that has a method on it called area, where we pass in a length and we get the length multiplied by itself, right? So the area of a squared is a length squared. So that's why you take that double and multiply it by itself. To test this, you import the square service, instantiate that class, and you could say, I expect the area is going to be 25. The actual area is going to be the square service dot area passing in the length, and I'm going to assert that the expected area equals the actual area. So this is an example of a unit test. Who has some ideas on how this unit test could be improved? Remove hard-coded values. So what would we use instead of hard-coded values? So that 25 and 5, instead we can, okay, external files, constant interfaces, etc. For this particular case, we also use randomized numbers too, because this is just looking at the test case of 5 gives 25. If we hard coded in the here, return 25, this test would pass, right? So it's important to ask, how small is your unit? How are you going to mock dependencies? And what is the depth that you're going to test? You know, that was a pretty small unit. If you had that area function, you might be like, pretty straightforward. Maybe we should just test the integration. And how are you going to analyze code coverage and how or if you're going to mock a database? So here's a unit test with mocking. So say we had that square service, now we're going to add the circle service. The circle service also takes in a length and gives you pi r squared, the area of a circle. And let's say we have an enum of square and circle, this type enum, and we have a calculate area service that in its constructor takes in the square service and circle service and has a method where you pass in a type and a length. And if the type is a square, then we return the square service's area. And if the type is a circle, we return the circle service's area. So here we have some options on how we test. One way we can test is we can mock out our square service and circle service and calculate the area, instantiate our calculate area service. And we can say when the square area is called with 5, return 25. And then run the calculated area with a type square and radius or length of 5 and assert that 25 is the return value from calculated area. So here we have our circle service or square service, and we have our wrapper around it, and we're mocking that square service and testing just the wrapper around it. And so there we're defining our units as the square or circle service and the wrapper around it. Depending on who you talk to, you know, like before the project I'm on currently, I thought this was the way to unit test. But it's been brought up to my attention and I'm starting to wonder, you know, if we should test those units of functionality or if we should test units of behavior. That when the area service is called for a circle, it gives us the radius or the area for a circle, and don't mock the circle method, area method. The same with the square. That if we test behaviors rather than functionality, test the public exports rather than the implementation, that we can still write cleaner code because we are having some unit tests, but we leave room for refactoring, right? So say we want to refactor the way we do this circle test, the circle service and square service. If we have a rigorous unit test around each level of functionality, then we're not going to be able to easily refactor the implementation. And so sometimes unit tests too small can hold us back. So this brings up, I talked about black box or white box testing earlier. Black box testing is saying, I don't know the internals. I don't want to introspect on the internals. I'm just going to test as a user and see that certain things happen. White box testing is introspecting on those internals and saying, when this happens, when I call this function, this should be returned. Some more examples: black box is hitting an API and expecting a response. White box would be calling a service and expecting your ORM, your object relational mapper, the database interaction layer, mock that and expect that to get called with what you were expecting from the service. Black box would be checking your DOM and expecting a component to exist. You have this div with a class. A white box would be testing individual methods within your front-end application or testing the state. For those that do React testing, you probably worked either with Enzyme or React testing library. And React testing library, it really pushes you to interact with the functionality as a user. It pushes you to click on things to check the state of what's on the DOM, but not check the state of what's in your functionality. Like, don't check your store, don't check your Redux store, don't check the state behind the scenes, just look at what the user can look at. Then again, it confuses things a little bit more because that's what Cypress has you do as well. It tries to give you black box testing from a user standpoint, and that's the same thing as React testing library. And with React testing library, it's even harder to unit test your components because it's harder to mock internal components, where it's easier to do shallow mounting in Enzyme. So all of this is driving towards that, focusing on behavior-driven development, focus on how users interact with the app, on the behaviors rather than individual methods, avoid testing strict implementations, rather test public APIs, whether that's what your component exports, what your UI sees, or your API public methods that other packages hit when they hit your backend service. Test overlap is a big topic. I don't think anybody really likes a lot of test overlapping, but we should make sure we test enough to make certain things like this not happen. So, finish out that example. Here's an API test for that. Let's say that we had a controller expose this shape endpoint where you can give the shape and the radius, and it'll call that method. And you can use a testing platform to test your API. This will be doing the same thing as your integration tests that we saw earlier, your unit tests we saw earlier. So how can we write quality level of tests at these different levels and enough tests at these different levels to be well tested, but not to cause too much overlap? So integration tests can be done within your unit testing framework, as I talked about. React testing library works fine for end-to-end testing. API frameworks that exist out there: Cucumber, Rest Assured, Postman, SOAP UI. UI testing frameworks like Selenium, Cypress, and Capybara. There's a couple of blogs I have on here that I found that talk really well about unit versus integration tests and testing code that talks to the database. These were out there for Java purposes when I was speaking to more Java-oriented crowd. What you don't want to do, though, is test your integration in production. So I'm probably preaching to the choir here. You probably all know that. So this is an example of a modal where you can unit test it, set up your sort of dialogue service, and set up your component, and configure the testing module here in the before each. This was part of what we did in Angular, the simpler of the methods, and then doing something simple like this. When you click, when you call a method, you expect your service method to get called. So we were using Angular material, and when we called a certain method, that dialog got opened. And so don't be confused here by the word click. This literally is a JavaScript function on our controller calling a function on the service. So there's no DOM interaction here. There's no actual button clicking happening. This add clicked gets called when we click the button. So that's where we can do this integration testing with testbed. This testbed was where we decided to only do our UI testing in Cypress, because it took a bit of work to do all this testing setup. But in here, we get the button on the DOM, we click the button, and we expect the dialog to have been opened. So same thing, but instead of just working on our controller level, we're now doing it from the UI. So integrating between the view and the controller. UI testing in Cypress, what this would look like is you log in, you visit your URL. Login would be a method that if you have any authorization you have to do. It's not necessary if your URL is exposed without auth. You click on the button, you get the element by a class name. This is a CSS selector if you're not familiar. And you get an element and say it should exist. Because it's such a simple example, we go through, we input fields, we do a bunch of other fields, and then we click the submit button and we assert that the mat dialog should not exist. So this is showing you at different levels between our first one, our unit testing. This is calling a method, another method gets called. Very small unit. Up to clicking on the DOM and asserting that a method gets called. A larger view, but still gray box, right? It's not complete integration of the UI. Here, it's the full integration of the UI in Cypress. We, as a user, click type, click submit, and the modal goes away. We don't ever look at the internal state and say, this method was called, that API was called. Although with Cypress, like I said, it does let you introspect on your API calls. So we could say when we clicked submit that we expect an API endpoint to have been called. So that is something that Cypress allows you to do. Again, or mock those API calls. All right, I'm noticing now that it's 4:59. So testing pyramid, I think that there was a little bit on CI/CD and when it happens within a sprint, and our regression, our non-functional testing, load testing, security and penetration. I'm not too much of an expert in these areas, but I did want to throw them out there as something that is important to test, right? A lot of us get, especially developers, get stuck in the nitty-gritty of functionality that we forget. It's important to look at the performance of your application, the security, and load testing, as well as usability. This isn't a UX talk, but my old UXer on our team would slap me if I didn't mention that usability testing is important. It's important to get your app in front of users, whether it's the real user, preferably, or just somebody else within your company. All right. User testing, getting your user in front of the application and trying it out, picking the right demographics for your user testing, whether you're going to guide them and tell them what to do or do exploratory testing. You know, that's just sitting them in front of the app and saying, hey, Click around, tell me what you think this app is trying to have you do. Then after all of this, you can relax because you have found all the bugs. Tongue in cheek. All right. So plowed through the end there. I'll go ahead and turn it over to our hosts and open it up for questions. Feel free to shout out in the chat for now if you want to. Is my audio working? Do we have Nick, Dusty, or Mike?
Yep, I still hear.
Okay.
Yeah, I hear you.
Yeah, I don't know if you guys wanted to wrap it up or
I was
wanted to
waiting
open up.
I was waiting for somebody to jump in with questions. That was a great presentation, Michael. Thank you.
Thanks.
Yeah, it was.
Hey, Michael, excuse me,
cool.
this is Jessica. Would it be okay if along with the recording, and I'm assuming, Dusty, that you're on top of this, but to get the links as well to the presentation in the repo?
Mm-hmm. Yeah, the this link should work. It's up there at the top of the chat, and I'll leave that out there. It might get updated, but probably only for the better.
And we will post these links in the video on our website as well. You can go to DACA's website and then look for today's event on the calendar. It'll be there.
Cool. All right. Well, thanks for having me.
And thanks.
I'm glad T-Volk, sounds like you say your developers will learn and like this. I'm glad to hear that. Not all developers are too fond on testing, so I'm glad to hear it.
Well, this is T-Volk. This is Therese. Yeah, I'm working at an organization that I'm their first ever ITQA, so it's been an interesting journey.
A learning experience.
Well, I mean, it's just a journey of like right-sizing the rigor, I guess, is kind of how I put it to my coworkers, and pushing the needle even, unwillingly or unrequested pushing, I guess is a better way to put it.
Cool. Yeah, I think most developers do, though, after they get into testing and see the benefits of it and the quality of the code that's produced and the bugs that are caught, even while developing, as you're unit testing, you catch bugs. And when you push something or commit something and your regression tests break and you're like, wow, that would have sucked if that would have made it out to prod. I'm glad that we have this test suite. Most developers come around.
Yeah, there's appreciation for sure. Thanks, Mike. Appreciate it.
Yeah. All right. Well, it was nice meeting you, Jessica, and everyone else here who joined.
Yep.
Thanks so much for the presentation. It was really interesting, and I'm glad I was able to watch it.
Cool. Good. I'm glad to hear that. All right. Well, I'm going to go ahead and head out then if there's no other questions. Yeah, good seeing you.
All right. Thanks again, Michael. Thanks, everybody, for joining us, and hopefully we'll get you back online with us next month.
All right. Bye.